Welcome, I'm Bernhard Rasinger, I'm from Vienna, and I am actually a trained engineer, like an electrotechnics engineer, and for a living I climb and service and inspect wind turbines. And I'm trying to make sense to myself also why I'm here and why I'm doing this with the laser, and this artistic process with using modular synthesizers and lasers. And I've prepared a little presentation about this, so that the first question is, why oscilloscopes? Why do I like oscilloscopes, or why do like we all gravitate, or like people from the vectorhack festivals, we kind of have oscilloscope collections, and it's very soothing to be among a group of people that also have collections, because it's something very rare, and it's very joyful to be among these people and find understanding in this sense. So the question, why oscilloscope? I work as an engineer, and this is one of the smaller turbines that I don't service anymore, and you can see at the top, that's me standing on the top. It's like a 1.5 megawatt wind turbine, and it produces electricity that is then fed into the grid, and that we all consume. So this is like, if you imagine a tree, that is the power system, and then it has all different power plants, like nuclear power plants or coal power plants. Wind turbines could be like at the roots, and then they all come together into a trunk, and transport this energy into cities and into industries, and where the energy is being consumed. And like all the leaves and the branches of the tree would be maybe the power sockets that we connect our everyday's computer appliances or synthesizers, lights, whatever you use that uses electricity. So just to make this connection, the vectorhack is very much like this idea of a vector, a point, and with an arrow pointing into a direction, and at the end of this arrow is another point. So it's a connection between 2 points, basically, and these 2 points somehow have a relationship. And I'm trying to go full circle and find connect those 2 points and make a circle of connecting the electric power with the synthesizer, and maybe show some circular movements, but I'm not sure if it will work. So that's one of the reasons. And then this year I was at the PIF camp, thanks to Ludmilla and Tina and the whole team. I enjoyed being at the PIF camp for the second time this summer, and there's a very nice photo that Katja made of me showing, I'm probing into the power socket, which you shouldn't do at home, but I'm a trained professional, so I'm showing that the phase, or what the voltage that is being transported through the energy grid system oscillates in a sine manner, or in a sine form, waveform manner, and it has and this is used. I used a digital oscilloscope. Like if I would be Robin, Batman would slap me into the face, but it has a readout. It measures the frequency, and it showed that this sine wave had a frequency of 50 hertz, which is like the grid frequency, which is like the hum. Sometimes you can hear it. Like nobody wants to have the hum on the PA system, but sometimes it happens, and that's like generators turning at a certain speed, and all the generators have to be in sync. They all have to run at the same speed, so so they don't crash into, or that these sine waves don't crash into each other, and we don't get harmonics. Yeah, can you pull it up again? This is the tone, or maybe this is also like an octave above, like 100 hertz, but this is actually a hum that comes from the grid, and that is all around us, and that connects us all in a way. Okay, then there was a short presentation in the summer, and this was the demonstration. And then why lasers? You know, that's I work with lasers, and I connect the modular synthesizer to it. And where does the fascination come from? And I asked myself, where was the first time that I saw it? And I remember being a child, and I know there was this Lego man, and you know this thing here in the front. I was fascinated by these parts that looked like lasers. I didn't know what a laser was, but it was, you know, it was this promise to the future that, you know, that you could go into space, and you know, back then I was a boy of maybe 6 years old, so I didn't watch Star Wars yet, so a laser was something very abstract, or I maybe didn't have a clue what it was. But I remember that these parts, these blinking lights, and especially these laser beam kind of plastic Lego parts, I was really fascinated by them. And so later, you know, of course, I saw the movie, and you probably all know Luke Skywalker, and another promise to the future, or like a utopian, like a science fiction possible future about good and evil fighting each other, and the father and the son, and so. It doesn't work. Then you also know this character. He also has a tendency with lasers, and then, you know, that's maybe those two gentlemen also. They work in the. Actually, a laser is like a resonance phenomenon that, you know, you have like a can, if you like, or a cylinder, and at one part of the cylinder there's a mirror. And the other part of the cylinder is also a mirror that is slightly translucent. And then you pump energy into this cylinder, and in this cylinder is a medium, like a laser active medium. And if you pump energy into the medium, things start to happen, like stimulated emission, it's called. And then, you know, like photons will go back and forth, and it will amplify themselves, and then at some point, like that half translucent mirror will, there will be emission. So and this is actually kind of, like this is also from the movie Star Wars, and it's when the Death Star, which is like the ultimate spot killer, killing planets. And this is kind of a laser cavity, and they have also like a beam in the middle so they can aim it, or it's like a concentric kind of laser functionality, but it's like very, I don't know how to describe it. It's very interesting light, or it's very special light. It's like monochromatic, so it's very precise. It oscillates a very precise wavelength, and so it's very high quality color. So it's fascinating to me every time I turn it on, and yeah, then maybe, you know, this gentleman, Jean-Michel Jarre, he's also drawn to synthesizers, and he has this laser hub. I think this was somewhere in the 80s. It's one of these gigantic concerts. I never saw him live, but yeah, he's also fascinated with lasers, and there's also this gentleman. So there's kind of a connection. So. And, yeah, it's cheaper than a laser to do it this way. Okay, let's move on. Then I use a laser, and I use a modular synthesizer, and often there's you know, you could do, with the computer you could do things so much easier. It's so much less to carry, or, you know, there are so many more options. And I kind of, I'm very bad with computers. I avoid turning them on and using them, because I get distracted by looking into the internet or checking emails 1,000 times a day. So there are a lot. For me, there are too many options in the computer system, and so I tend to gravitate away from them. And I found the modular synthesizer to be something maybe that also relates to the first picture we saw, this Lego man. Like it's a thing that you can build up yourself. You have these building blocks, and It's like playing Legos or toy trains for grown-up people that like cables. And also, like in the 70s, this advertisement from Roland, there's this promise into the future that you have this kind of runway spaceship and that you know, takes you forward, and you have cables flying your way. So I don't know why it's like, it feels like, and that's like this picture. Sometimes I imagine myself like when I make this setup, and I hardly perform on stage like I do now, like confronting an audience. But I will demonstrate this the system later. And what I like to do is like sit among the audience. So I'm part of the audience. I see the same thing, and I hear the same thing. Or like also I want the best sound. So the big system is usually for the audience, and if you're among the audience, you have the best sound. And then in a way also I found out during like practicing this or like showing this to people that like if we all see the same thing, we can agree on that we saw the same thing, or like it's a matter of perspective. If we all agree that we have the same perspective, it's easy to say, I saw this, I saw a circle, I saw these kind of shapes. And of course there's some opposing parts, but it's just twisting this the audience and the performer in a way that I'm also part of at my performance I'm part of the audience, because I need to see what I'm doing. And so you can maybe think about it as like this is a spaceship, and then this is the window that we are flying, like we're looking out the window and we're flying into this abyss of shapes, and I get to be the captain on the modular synthesizer steering wheel. Okay. So this is a jump now. The talk is called, I called it, when I wrote it to Derek and Cliff, it actually has the wrong name because I didn't think enough before I wrote it out. The Schizophonic Life of Resonant Filters, and it should actually read the Schizophonic Life of state variable filters, which I'm going to demonstrate later. And it's just very short. I'm not going to like do a very technical description about it, but state variable filter is an active filter, so it needs to be powered by power, and it consists, like we saw Joost talk, it consists of basic functions from an analog computer called integrators, like one or more, like most of the time it's 3, or it can be different configurations. And then the output of these integrators go back into the input and then create a feedback loop, and then this filter has the possibility to oscillate and become a sound source as well. And basically a filter in an audio configuration, this is a circuit diagram, and so you have an input where you can put a signal into it, and they will go through these integrators, and then you have different outputs at the bottom. And with this state variable filter, it's a nice feature is that you have that the filter can filter different parts of the harmonic frequency spectrum. So you can have a high-pass filter built in this, so it will only let high frequencies through the filter. If you think about the filter being something like a sieve that you like drain water into, or the noodles that you, and then the water will go through. So the water would be like small particles or high frequency content, something that passes through. So like high-pass filter is something that lets high frequencies through the signal path. Then a band-pass filter is kind of a hybrid between a high-pass and a low-pass filter that only lets through certain areas in the frequency spectrum called a band, and the low-pass will only like pass the low frequency content. So here you see the responses, the response curves. You can, because this is a variable filter, you can change the so-called this frequency here. You would call cutoff frequency. So the frequency where the frequency content will be cut by the filter, and then you see the low pass response will. Here you have voltage gain, and then you see attenuation over the frequency spectrum. So you have like zero oscillations or no frequency, and then this is up to like the human hearing goes from 20 hertz to 20,000 hertz or 20 kilohertz, and so you can cut different areas of the hearing range if you want to, like very bass sounds will be like a low pass filter response, and I will demonstrate also the different responses later in the thing. So I don't want to go like too deep into the technical aspects of it, and maybe show more about the system, and then also maybe let people try and like see all the cables and just turn knobs to it. I think this is the most fun. Okay, and then to come back to the title of my talk is the schizophonic life of these filters, and or the schizophronic life. And schizophonia is something that I came across working together with an artist from Copenhagen. Her name is Anna Samsø, and she's very much diving into different phenomena that affect the human body, like by sound, and or by perceiving sound as an input to the human body, and like there are effects like scales of solfege that affect like certain frequencies that are very good for the body if you expose yourself to them, or it's like some of it might sound like a bit of voodoo craft, but I picked up while I was working with her on an exhibition that this aspect of schizophonia, which was coined by Murray Schafer, and who is a composer and also like a writer. This is out of the book The Music of the Environment, and so it's to describe this splitting of an original sound and its electroacoustic reproduction. And as I understand this, that as soon as you have a device, a mechanical device or like a machine that can record sound like a phonograph, and that can take, like now that we are talking, or that like I'm talking, it's obvious that, you know, you can see my mouth move, and it makes sense to the brain that is listening to me that the sound is coming from my mouth and that it's in perfect sync. And as soon as you take the sound away from its original source, like a violin player, you would see the stroke of a violin player, and that the gesture would make the sound, and it would make sense in a way that where the sound came from. And as soon as you deal with reproduction or like electric acoustic systems like speaker systems, or where you can send also information and sound in sound files around the world, you tear apart you tear the sound from its original source, which in my understanding creates a conflict in the brain. It's something that we perceive as uncomfortable, and I will show you a little example of this. So one back, which is this movie clip, and what I did is we will just watch it, and I unsynced the sound track from the video track, and I hope it still works until reset. And what happened?
That was part of an animal who chanced to swallow a floating mine. I wouldn't worry about that either, Miss Frank. You there, Miss?
Comrade Tanya Irenia, Tanya Karenska, Alison. I am from the Moscow Bureau.
You grace us with your presence. May I be of service?
If you please.
Of course, you could watch it,
The mask to give the better picture.
but it's very uncomfortable to perceive this because the brain wants to see everything in sync, or tends to want to see things in sync.
As a stranger to our shores, your request is not unnatural, however impossible to grant.
Impossible.
It's just a second of delay. Like I overdid it a little bit, but it's okay. Oops. Okay. Here's Robin. He has his mic on, and yeah. Well, there's no slap, I think. But just to give you the idea of this schizophrenic idea that you separate the sound from its source is something that can create discomfort in our sensory system, because like we are very much highly tuned sensors. And we have a very good hearing range, and we see, I don't know, like 1,000,000 colors, and we have it's amazing what the human body is capable of, and also the brain works subconsciously. It always tries to make sense of the environment, and in that sense, sometimes you would go and see maybe a concert, and you have a light show, or you have, going to a concert can be a very spiritual, uplifting moment, that creates goosebumps and shivers up your spine, because it can be overwhelming to perceive sound and live audio performances, and often if you have accompanying light show that is in sync, or that somehow relates to the sound that you hear, it can be even more uplifting, or it can make much difference. But I work very much with this schizophrenic phenomenon, because as I will explain, I visual all the signals that go to the speakers. So I call this the duality principle, and it's a very simple principle. It's so there are two speakers in a stereo system, left and right, and on an oscilloscope you have a screen that creates a Cartesian coordinate system that has an x-axis and a y-axis, and so if the signal flow of the system of my system is that whatever I show on one of the axes goes to one speaker, and only that, and the other signal is hardwired to the other channel, and then you have a very, very distinct. Then you have these two entities, or these two channels that can work together, or that can oppose each other, and. For example, if you have the same signal on both channels, and the speaker cones would move the same way, in phase, they would do the same movement at the same time. They would move like this, and if you opposed them, or if you changed one of the cables around, or at home you can change the cables. These ones are not possible because it's XLR cables, but if you change the phase and inverted one of the signals, so it's exactly the opposite signal, it's that the speaker membranes would move like this. And I can show you later on the laser what that would look like. And the interesting part, I think, in vector graphics using oscilloscopes is when there's this phase relation between the two signals that have a 90-degree phase shift. So it's one signal following the other by a 90-degree phase shift, or it's just dragging behind a little bit, and it's like one signal saying, like asking another signal for a dance in a circle, and like if you oppose each other, then it becomes this like marching dance that you do at balls, and that like people come together and they go apart. But if you want to twist things around and on a Cartesian plane, then there's always it's always interesting to have a 90-degree phase shift. Okay, so I hope this somehow made sense, or this was a short introduction. I think it will make more sense now that we look at the actual waveforms and we listen to some filters. Are there any questions so far, or can I? Should we just turn the laser on and look at this? I think it will be fine. It's so we'll close this down. This should be. Usually I don't talk, and I will try to explain what I'm doing, which hopefully there is also. Okay, there's a signal here. I haven't tried this before. Just need to set this up, and I ask you, please, if you want to, please don't go through the beam, because it can be dangerous for the eyes. But everything is safe if you stay in your seat. And it's just very dim, and I don't know why. I should have, but we tested this before. So this. Can I have the hum that from the mixer? I will now tune this oscillator, or try to tune to the frequency of the grid frequency, and so now I can sync with the grid while the generator is turning and feeding energy into the grid. I'm running one oscillator now at the same speed. I'm using an oscillator that create two signals, and they can phase shift filter to the image, and if you remember, I talked about the state variable filters having 3 different outputs, like a low pass, a band pass, and a high pass. And the quality of these filters can be that if you applied 2 outputs. So now I have a sawtooth wave going into a filter, and then I can, like, if I apply the low pass filter, I can take the edge over the very high frequency that makes a clicking, and it will be more like a dim pop. So you can instantly hear that, you can see that the edge is being taken away. And if I self-resonate the filter, maybe let's turn the frequency a bit up. If I self-resonate the filter, you get a beautiful spiral around. This is a bit too loud. You get these beautiful spirals, and it's like watching I think it happens because lower frequencies travel much slower than higher frequencies. You get these very nice cones that kind of 3-dimensional looking. Let me see if I can enhance this a little bit. So if I scan. So now it's like I have applied, like this is the basic form. Like I've applied this signal to. It's very boring sound actually. If you don't animate it, it's just a drone. And if you turned off the image, it would be even more boring. And so like when I perform, like really half of the rent is having the laser, which has this very nice bright light and like these intricate colors. You can you have 3 colors. You have very nice red, which is this Darth Vader kind of red. Then there's the Luke Skywalker blue or white. You can make it. You can like mix different colors with all these different. You have just plain blue, and if you mix red and green, it becomes this kind of yellow orange, depending on how much green you mix in, but you can make like sunset kind of. So, but now this is a representation of the resonance of a state variable filter, and by sending 2 outputs of the filter, like there's one input into the filter, which is like a ramp. It's just a rising edge coming down very fast and then rising again, and running through this filter and feeding the filter back, or like this, the architecture is that you can feed the filter back into it, and then it creates this resonance. And if you sweep through the cutoff frequency of the filter, you can play with this cone. And then if you crossfade between those 2, maybe let's get a little bit bigger, silent. If you crossfade between low pass and the high pass, you can also twist things around and make them look 3-dimensional. Of course, it's just a projection on a flat wall, but it's very. I think it's a very nice effect, and it's a very simple. It's a very simple building block in a modular system. It's an oscillator and a filter, and of course I can manipulate voltage control the filter and make it wobble, or try to tune different frequencies on top, and they make all these nice shapes. And you can see that the system is very responsive because it's very direct. There's hardly any latency, because at the same time I'm sending the the signals to the speakers, they also go to the galvo system, so the deflection system of the laser beam. So it's very comfortable for it. You can easily create these hypnotic moments because it's it opposes this schizophonic principle that you have an instant representation of a sound that is actually unperceivable in a way, because it's an electric signal and you can never see the membrane move, or if you that the sound is coming from the speaker membranes, but you would never see the representation of the membrane is moving so fast. It's not like you're seeing somebody talk and moving the mouse. So this is, I believe, is why this can be very hypnotic to watch these kind of figures. If you show them directly on the screen and listen to them at the same time. This is actually how I started looking at these waveforms in like connecting a synthesizer to an oscilloscope and just being hypnotized by the beauty of these simple structures. And, this is one filter that I won't go into like all the specifics, or maybe we can have specifics in a question round after. But I think the time is 40 minutes. I will quickly go to another filter and show you another filter response.
One thing I just wanted to say about that, which was kind of interesting, is there's a visual ambiguity in that shape where is the point of that cone coming at us, or is it going away and your eye flips it around? And
yeah, you never know. It's like it's a trick on our visual perception.
Yeah, it's our brain making that. We want to see a pattern in it.
Yeah, we want to see this three-dimensional thing, even though it's not. But I'm amazed every time. So let me just find the knob. Sorry, this was very broad. I actually built a spot killer for my laser again, because like if I turn the laser on like this, it's very uncomfortable to look at. So when I play shows, it's very dark, and so I made like a very simple patch in the system that allows me, like if I bring in like a signal, it instantly will become bright, and if I turn the signal away, it dims the beam immediately, so there's never like a bright spot that is uncomfortable. So I hope this is only one channel, so you would hear only. Now we only hear the right channel, and you can see the representation of this is only one line, but it's very boring. If we disconnected this and showed you the other. So now you can hear the signal coming from the left speaker, so you can really see that it's a hard panning system, and the XY representation is left and right. If I combine those two signals, which have a 90-degree phase shift, they make these very nice spirals, and this comes from a module that Derek also uses in his performances, the pendulum from Rob Hordyke. And if I play around with, it's like an oscillator and a state variable filter, and you can also make these spirally images. So maybe this one is, let's see. There is instant fun with just looking at this. And you can hear like now there's a lot of high frequency content resonating, and then you can cut it away. But and then the filter, if you hit the fundamental frequency of the oscillator going into the image will expand and it will become very loud, because the filter circuit starts to resonate, or it starts to amplify the waveform by resonance. Which
is that square that we see? Is that simply clipping?
The square is just it's a very hot signal, and it's going into like a digital module afterwards, and it's clipping.
So it's clipping, okay.
It's clipping. But if I try to not clip this, then it will look like this. And then of course you can apply all kinds of effects to this. So this is like I use these filters as a source of a circular source, and then you can of course manipulate them and chop them apart, or like apply different comparators, and like now you can see again that there's a duality system that you can only hear one line to one speaker and the other to the opposing channel. So you can cut things apart, or you can decide to draw these images with less points, like sample rate reduce the whole thing. And I think I had another filter that I wanted to show exactly. Let me just so here you can hear that if this is another resonant filter, and you can instantly hear this this very nice sound that is very. It's also like a promise into the future. It's almost like a vocal sound saying "wow." It's like it's I don't know. Like some people don't like this, but it's called a resonant filter sweep. I'm very much I don't know. I'm drawn to this sound somehow. I used it a lot in the performance in Zagreb, and this is it's the magic of resonant filters, and they make these beautiful spirals. And I think, let's see, I think we should conclude. Maybe there are some questions, or people want to like turn knobs and play with the system a little bit before I give the word on to Roland.
Do we take questions or do we nerd out? Okay, we have one.
I saw that you have the clouds module, which I think is for reverb.
Yes?
Do you use reverb just on the sound part, or also on the visuals?
Well, that's a very good question. I use all the sound goes to the system. So I have a reverb. I have this is patched. I can apply a reverb to this figure, and you will instantly see that the reverb will change the image, and will also change the sound. So if I apply the reverb now, you can see that the spiral is not as precise anymore, because the reverb algorithm also changes the phase of the signals, and the sound changes. And this is very, very much the principle that I was talking about, to show everything that you to show everything that you hear. So it's there's no mistake that the eyes see something different than they hear, or like a very close representation of what the ears hear. And there's also another. I can show you another reverb patch maybe real quickly, which is this one, which is actually just a basic triangle wave. There's just something else here, which is a triangle wave like this. And if you apply, which is a single signal, and if you run it through a reverb algorithm, the reverb will interpret and calculate the spatial sound, and will change the phasing of the signals, and then give you two outputs that I apply to X and Y. So it's an easy finger trick to do something like this. I think this was also like a big part of the show in Zagreb, and you can have this kind of Vangelis drones. it's very soothing for the eyes, and because you see a very direct representation of the sound. It's very reactive, but it's very direct. Of course, it cuts some parts because the laser is not as fast as an oscilloscope, obviously, but the benefit is that you can show it in front of large audiences and big spaces. It's very good to share it this way. You can all, like a lot of people can see the same thing and then maybe agree on it, what they saw.
I have a question actually, which is, of course, there's two kind of danger levels in these experiments here. One is, of course, the danger for the eye if if the audience gets in the way of the beam.
Yeah.
The other is actually the danger for the laser, and especially when you're working with the modular system, it's entirely possible you might send a really high frequency signal to the laser that might be harmful to it. How do you cope with that in your setup?
Well, in this setup, I had no clue about any of this, and I just had this idea that it would be cool to have oscillographic images on a big wall and share them together with an audience. And so I started my journey with diving into this modular world, and somebody pointed out to me a company called LZX, Lars, and I wrote an email to him. It was also like a person that I didn't know him, or like in person. And I said, well, you make modular video synthesizers. You understand that I want, or he understood that I want to make something visual. He wrote back to me saying he doesn't have any resources, he doesn't know anything about lasers, and but if I can specify what I want from the circuit, then he can make a prototype. And what the specification was is like a low-pass filter, because the modular system speaks the same language voltage-wise as these standard laser projectors. But sometimes they speak too fast, so the frequency is too high, or they speak too loud, and then they have these little mirrors. They would just you would just overshoot them. So there's a clipping circuit inside this interface module and a low-pass filter that is kind of tuned to this specific projector. If I connected another projector, it might burn the galvas because it might not be fast enough. Well, it was just try and error. Like the first prototype was, I think, at 18 kilohertz, and of course it burned. I had another projector that was much cheaper than this one, and so I burned the deflection system very fast. But then I had some reference where that happened, and I said, well, we have to limit the frequency much lower. And I think now it's 12 kilohertz just to get all the transients and or these high frequencies off. And then internal system, it's really not specifically tuned that you would say you take a screwdriver and say, okay, now this is super precisely tuned, but the experience that I have with this system is stable, and no matter what signals I feed into it, it kind of it doesn't destroy itself. So I'm happy with this state, and I think Lars also made an iteration or another revision of these prototypes, and made a product for the market for everyone to use and to have different filter settings for different projectors.
Maybe to supplement that a little bit, laser projectors are rated in something called kilopoints per second, which has no real correspondence to a frequency cutoff in a filter at all, because there's so many other factors like how sharp a turn it needs to make, how far it needs to travel, all these things. So it's when Lars was doing this work to make this Cyclops module that he calls it, it was a lot of plug and pray and just guesstimating things quite a bit. So, and when you talk to people in the laser community, they now, the laser community can be a little bit funny, but and they tend to just want to shuffle you off to some very expensive packages, as Ted was mentioning earlier.
That's very fun.
Or they're super engineers, and they start speaking in a language of mathematics that is beyond my comprehension, at least. So It's a lot of trial and error. I think I'll probably be doing this process very soon for the pure data library, and I'll have to go through the same thing. I'll just have to try setting things very conservatively low and incrementally increasing them to see what happens.
Yeah. It limits also like my sound, or the sound is very like low pitched, so it's like low pitched drone, and it sounds like the horn of a big ship. And but it's also because the laser can't take high frequency, so it doesn't like it, and so it kind of limits me to the lower frequency range of the spectrum, which makes me a drone artist, I guess, in a way.
Just think in terms of harmonics of the power grid, you'll be fine.
Yeah. No, it's I like low 50 hertz hums. But, yeah. So like.
Yeah, I would say. Oh, sorry, there's a question. Ida?
A very practical question. When you're exercising, do you always use this kind of projection? Because from my experience, after like even in the performance on Wednesday, which was fascinating, but after like 50 minutes it becomes very psychedelic.
Yeah.
How do you practice?
I have a studio where I can set this up and where it's safe, so there are no people walking around the room, and it's funny that like the practicing is very much like just turning knobs and like playing with the cables, and like happy accidents. I find out that like this system is like I'm not using the computer because this is very like it limits me to like this like what is in the box. And when I practice like if I really make the room dark, then it like now there's a little shine on the screen here, so you can still see the screen. But if it's complete darkness, and then you lose the sense of the space, and I lose time. I have this little time device here. I had to make this because usually when I do and also I perform, I lose the time completely because I'm hypnotized. Then sometimes I'm like, oh, okay, now it's getting boring, and maybe it was just 5 seconds, or I tend to lose the sense of time performing. So
I think a lot of us in this.
Yeah.
Sorry.
The eyes also, I need to take breaks, or like I usually don't perform longer than 40 minutes because it gets strenuous for the eyes, and people like you don't want to uncomfort the audience, or I don't want to. But it's like this time, like I think it was a bit too long. It could have been shorter, and then people like maybe had the feeling like they could have had more instead of like it was slightly too long, or like it was already like getting hard on the eyes. It's just, but it's like a sensible thing, border.
Concerning this last question about basically strain on the eyes and how it works, I think it applies to most people or all people on this festival. I find it first you're in this feedback loop situation, but basically you twist the knobs and make image more and more satisfying for your eyes. So actually quite psychedelic experience, and also I think something happens to brain and I don't know what parts, but I'm, for example, definitely more resistant to strobing or fast changes because I do it a lot. So something changes, but it's I think it's yeah, we can talk later, but I found some cases where I can see the change from 20 years ago or 30 years ago, how I think my brain behaves now.
Great. Let's we could wrap up the Q&A a little bit, but there should be still some time if people want to come and play with the system. That involves people moving around. Please don't walk in front of the beam again.
I will turn it off,
okay,
so people can we can take a break, or like this if somebody wants to walk through. And I will get this off.
So your people can still come and play.
Thank you for.
Thank you very much.